Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Insert Greatest Common Divisors in Linked List. So you will be given the head of a linked list, and in each in the linked list, each node contains an integer value, and between every pair of adjacent nodes, you have to insert a new node that is having the value equal to the GCD of those two adjacent nodes. Okay, so what I mean to say is, let's take the very first example and let's try to understand what we have to do. So this is the example that we will be taking, and let me draw these links again. So this was the original list that will be given to you, and this will be the head of that linked list. Okay, so then what you have done here is, I will be circling those nodes that we have freshly inserted. These are the nodes. Okay, and these were the these will be the new links that will be formed. Okay, so see, 18 and 6 were adjacent. We took a GCD of both of them, and then GCD comes out to be 6. So we inserted our node of value 6 between 18 and 6 nodes. Okay, similarly, we will be doing for 6 and 10. So 6 and 10 GCD comes out to be 2. So a new node with value 2 will be inserted between 6 and 10. So this is what we have to do. Between every pair of adjacent nodes, you have to place one node in between them, which is whose value is equal to the GCD of the values of two adjacent nodes. Okay, so let's proceed further in the problem statement. Then you have to return the modified linked list after this kind of insertion. Okay, and the greatest common divisor is the largest positive integer that evenly divides both of the numbers. Okay, so I hope you are familiar with what a GCD is. Okay, and before thinking of an approach, let's have a quick look at the constraints also. So according to the constraint, the number of nodes in these in the given linked list will be ranging from 1 to 5000, and the values in those nodes will be ranging from 1 to 1000. Okay, so these are the constraints. So let's quickly think of an approach how we can solve this. Basically, a very straightforward approach that is coming to my mind is, we can do a simulation just doing what we are told to do. Okay, and then the problems comes down to the implementation of the simulation. Okay, and for that what we will be doing is, we will be using two pointer kind of approach. Okay, let me change some color here. So let's say this is one of those pointers. Initially we will be, this previous pointer will be pointing to the node previous. So see, if this is the pair of adjacent nodes, so previous will be pointing to the first node, and there will be another pointer which will be current, which will be pointing to the next node. Okay, in case of every adjacent pairs. Okay, so then what we will be doing is, we will be starting our previous and current. Okay, basically these nodes will be here in these pointers will be pointing to the nodes in the original linked list. Okay, just for the sake of clarity. And then once you are having the nodes, you know, hold of those nodes, then you will find out the GCD of these two. Okay, so GCD of 18 and 6. So, and if you want to know that what kind of algorithm or approach we will be using to find the GCD, I will be explaining that in the code itself. Okay. So for now, let's consider it as a black box. We are not worried about its how it's implemented. We are just uh, knowing that this will give us the GCD. Okay, when we will give it two numbers. Okay. Now coming back to the approach, then once you find the GCD, you will take that value and form a new node. Okay, just like we did here. Then let me erase these links. Then once you are having hold of references to the previous node, the current node, and your new node. Okay, so you will update the links. So what I mean by updating the links is you will break this link and make the next of the previous node to the new node. Okay, and since you have inserted the new node in between, so new node should be pointing to something. Okay, then you should also make a new link here between the new node and the current. So new node's current next will be current, and then simply what will happen is, so since we have inserted and the next previous node will be the current node, so previous will be coming in place of current and current will be moving to one place ahead. Okay, to the next node, which is 10 by the way. Okay, so here 2 will be the node that will be inserted, so current will be moving here. Okay, so this time current will be at this particular position and it will be gone from here, and previous will also be gone from here and it will be coming to its new position, which is this one. Okay, and the whole process will again be repeated. So this is a brief overview of how the process will look like, or the algorithm will look like, which we will be implementing. Now without further delay, let's have a look at the implementation, and things will be more clear to you in the implementation part if you are still not clear with how we are approaching this problem statement. So let's take a fresh slide for that, and this is the implementation. Let's see what we are doing here. So see, as I already told you that we will be using a sort of two pointer approach. So there will be two pointers, previous and current. Okay, in every adjacent pair, previous will be pointing to the first one and current will be pointing to the second one. Okay, then we will be doing a linear traversal of the linked list. Okay, and this current pointer will be helping us to do so, because when we will reach the end of the linked list, there will be no next node and it will be null. So till when your current becomes null, you will be doing this whole procedure. So what is the procedure? The very first thing is, since we are having hold of these two nodes, the adjacent pair between every pair of adjacent nodes, so we will be taking their values. Okay, and giving them to the get let's say GCD Euclidean function. Okay, so I will be talking about it in a little bit, but for now let's just focus on this particular portion. Okay, so let's say this gives the GCD value of uh, between these two values. Okay, GCD of these two values. Okay, and it will be of a integer type, so you will be making a new node out of that. Okay, and this will be the value of that new node. Okay, so once you have formed the new node, then you are having something like this. You were already having previous and current node, now you are having a new node. Okay, now this new node is to be inserted between these two nodes. Okay, so the insertion is to be done here basically. Okay, so how the new picture will be gonna look like is, so this will be your previous is next will be updated, so this link will be gone. Okay, and it will be updated to the new node. Okay, so let's use yellow for new node. Okay, and then new nodes next should also be pointing to something, and it will be pointing to the current. Okay, so it will be pointing to current. So now the insertion is done. Now we will be moving the previous and the current to their new positions. So previous will be taking the position of current, and current will be going one node ahead. Okay, so this is what we are doing. Firstly, the first thing that I told you to do is that previous is next should be updated to the new node. It is done. Then new nodes next should be updated to the current. It is done. So both of these are done. Then previous is new position will be updated, which will be equal to the current's position, the reference of the node basically, to which current is pointing to. And then current's next position will be updated to the next available node. Okay, so this way, when while we will be done with this particular loop, we will be having the linked list that we need to return ready with us, and then we will simply return its head. Okay, so this is what we have to do. Now let's have a brief discussion of how this thing is, this DCD function is implemented. Basically, it is using the Euclidean algorithm. Pardon me if some spelling is incorrect. I hope it does not affect your understanding. So if you are not familiar with this algorithm beforehand, then I will provide link of an article describing what this algorithm is, and a detailed explanation of how and when to use it and its time complexities and everything. Okay, so I will be telling you in a brief way what it is based upon. So it is based upon the fact that if you are finding GCD of two numbers, let's say a and b, and let's say a is the greater one. Okay, greater or equal. Okay, then GCD of these two numbers will be equal to the GCD if the greater number is reduced, okay, by this to this particular value a minus b. Okay, and the GCD will remain same. So this is the property that we are using here. And instead of doing, and see, every number divides 0. Okay, so 0 can be divided by any number. So mathematically, if you say GCD of 0 and a number a will be a itself. Okay, so because a is the higher one, and obviously it will be the GCD, greatest common divisor. So instead of doing this whole operation again and again, subtracting again and again, we will accelerate the whole process and use division instead of that. Okay, so when you will be taking modulo of a with b, so this whole thing will be converted to a range, and the range will be from 0 to b minus 1. Okay, so so then you see, if even if a was greater than b, then it will be now the smaller one, and b will be the larger number. Okay, that's why we are replacing their roles. Okay, so in a way, next time this will be like this. Okay, so b will be having the value of a modulo b, and a will be having the greater number, which is the b, obviously, because see, this whole thing will be reduced to less than b. So that's why doing the swap here. Okay, so this is a sort of way to accelerate the whole process of giving this doing this subtraction operation. So the whole logic or the whole property on which it is based upon is this particular one. Okay, and if you are interested in finding about more about it, then please head over to this link in the description box and explore this algorithm. And now, although you could have used any inbuilt function also, but just for you know giving you how you can implement it on your own, I use this particular Euclidean algorithm. And now I think after going over to the link, you will be pretty much clear about it, how this is implemented and what are the various things related to it in depth. Okay, so uh, now we will be talking about the overall time complexity. Okay, so time complexity wise, let's take a fresh slide for that. So time complexity wise, see, we were doing a linear traversal. Let's say there were n nodes. Okay, number of nodes, and for each adjacent pair of nodes, you were doing that, calling that GCD function. Okay, and the complexity of that GCD function is log of minimum of a and b. Okay, so this will be the whole complexity, and if you want to consider it some variable, let's consider it k, so n into k. Okay, and space complexity wise, see, we are not using any extra space here, so just using couple of pointers or variables for helping us to insert the nodes in between every adjacent pair, and other than that we are not using any extra space. So space complexity wise it's constant. Okay, order of 1. So these are the complexities and this is the approach. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough provided some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.